Yeah, go for it. And welcome to this Ladyada.
Hey everybody, it's me Ladyada at my desk and doing a little update video on this fine Thursday. Been a little bit sick, but I got some work done recently, so I thought I would do an update vid where I basically show kind of the things that I've been working on and just touch base on a few separate projects. So first up, I'm sending out another prototype panel, which is cool, so let's check that out. When I do my prototypes, I don't do what a lot of smaller, like Tindy sellers do, which is, you have one board at a time that you're working on. I'm usually working on like 6 or 7 different designs because, you'll put together a prototype and then realize there's like a mistake and you have to order some extra parts or like the PCB has a mistake in it. And so what I do these days, compared to how I used to do them, is I send out a whole bunch of prototypes at once. So I panelize them by putting them together in Eagle CAD. So this is the CAD software I use, so familiar, version 6.4. Safe. And I have a couple things here. First up, I actually have some testers as well. So this and this are testers. So this is like a sequence tester, and this is a tester for a product ID 1580 or 1590. For the Metro, for PID 1480. So these things down here, these few 6 boards here are testers. And we do make testers using the other mill to start, which routes out the PCB. But while that's good for getting started and designing a tester, they're not terribly durable, especially if you're doing a lot of pressing and pogo pinning. So what I'll do is after I get the prototype done on the other mill, I will get finished PCBs made at a PCB house. So I just save these up, and then these are the ones that are recently needed. So NeoPixel Feather Wing, this is the tester, and you can see this is the feather outline, and it plugs into an Arduino. I like using Arduinos for testers because they're inexpensive, they're durable, and they're really fast. And that's what I like about testers. I like something where you can, start the whole thing over and get testing very quickly. So even stuff that is not necessarily for use with a Arduino, like a full feather or like this, I'll try to put it on Arduino if possible to just make the testing procedure really, really fast. So we have a couple different Arduinos. Sometimes I'll use like an Arduino Zero or if I need I2C or an analog output.
Also notice you moved to the Metro, the Adafruit Metro, because you added a bunch of developer hacky friendly things.
Yeah, well, when I mean Arduino, I actually tend to use a Metro, and the reason I use a Metro is because they need an on-off switch to make it easy to really do a hardware reset because testers, when you're testing things, especially I2C, you can really mess up the microcontroller because you're connecting things and disconnecting them, and you can put it in a weird state, which is fine because normally you don't disconnect and physically connect, disconnect, and hot plug things on your micro. So having a switch is good, and also being able to change it from 3-volt, 5-volt logic, because some of the things require 3-volt logic testing, especially the feather wings, because they're all 3-volt logic. So I'll just cut the trace on the Metro and make it 3-volt. And then I've got some new designs. So
that might be a fun show to do one day, where you get a proto,
yeah,
and then you show all the features that you made with the Metro, which is geared more towards lower cost and also more hacky. That might be a fun thing.
You know what I might end up doing once the Metro M0 Express, the Circuit Python, MicroPython version is ready. I might do some of my tester designs in Python. Why not? For if it's about the same speed, and it can make it easier to adjust the tester. I don't know. I could try it, see how that goes. I also have some new designs. So I'm almost done with the bonnets that I designed from the last batch. A couple months ago, I designed 5 or 6 bonnets. So I'm slowly getting through those. The arcade bonnet is the next one that's going to be released, and then I have a couple more, including a LoRa radio bonnet, and like an LED bonnet. And this is somebody emailed and was like, hey, can you make a proto bonnet? And I was like, oh yeah, that's a good point. We have a proto hat, so this is the bonnet version. You have a strip of 5-volt power that goes over here, 3-volt power, breakouts for all the pins, and then this kind of 3 connect grid sort of. You can't have a full breadboard, but you can have kind of a half breadboard, and then it's Arduino Pi Zero shaped. And then this was one that I was talking to Phil B about. So it's his a little game pad bonnet, because we've been working a lot about improving and making retro game easier to use. So I thought, okay, well, how about we can make a little game controller that you plug in, and then I designed it so it's surface mount, so you don't have pads sticking into your thumb, so you can grip it, and then the USB and HDMI cables come out here from the Raspberry Pi Zero, so that could be fun. And then you have the little thumb stick, and then select star X, Y, A, B, and then I want to basically make this and then adjust as necessary to make this fit. And then I added 2 more buttons, 1 and 2, just for player select.
All right. For the little joystick looking thing, could you use soft buttons with it, or can you mod it, or would you have to make another version for that?
What do you mean soft buttons?
Like squishy buttons.
Well, these are going to be somewhat squishy. They're surface mount. I mean, I have to make them so you can press them. They're not going to be the really big buttons. I might end up redesigning this to use the really big, fat 12mm buttons. Right now, these are the 6mm. Basically, I'm going to put this together and just try it. And if I, the Pi Zero is this big, and if I get to play and it works out, I think it'll be okay. I do like these controllers. What I might do, and this is an analog digital converter here. What I might do is make another version that has 2 of these, like a little RC controller type thing. It's not good for video games, but maybe it'll be good for other kind of control interfaces. And then drop this XYAB, just have 2 of these thumbsticks, and 2 buttons in the middle, or maybe 4 buttons in the middle. I don't know, we'll figure it out. See how this goes. I just put this together today. See how it goes. And then this is the APA 102. I showed that little 8x8 grid a couple days ago. So this is the Featherwing version. I just took the 8x8 and then I split it in half. This is a 6 by 1, 2, 3, 4, 5, 6, 7, 8, 12, I think. Yeah. So it's a 6 by 12 grid, which means 6 characters is nice, because with 6 characters you can have a font, not a great font, but you can have scrolling text. A bunch of capacitors on here, clock and data. This is a 2-wire protocol RGB LED, so I think this will look really cool. TPL 5111. So I also did that video about, this was a week and a half ago, about the TPL 5110. That's a chip that can do power gating, and it's for it has a pass transistor that actually turns off your entire circuit until a timer occurs, and it'll turn it back on. This chip is very similar, almost identical, except instead of controlling a transistor, it controls a single pin that you would connect to your enable pin. So it's opposite polarity. Instead of turning on a voltage when you want to enable something, you turn, instead of, I think it was dropping the pin low, which would turn on the transistor, instead it raises or lowers a pin to your enable pin. Most enable pins on microcontrollers, except for very, very rarely, enable pins tend to be, you pull high to enable, or maybe it's disable. Usually you pull high to enable, and so this would pull the pin low. Maybe it's the other way around. I'm trying to remember. I'll look at the data sheet. I remember K-Town actually did this design. It's the opposite. Whatever. And then this is the PCF 8523 RTC plus some crypto chip, CryptoWing. Not sure if I'm going to get around to the software for this, but there's been more code released by Atmel. So these are some crypto chips for the Feather line. These are all I2C chips. So they can do some hashing functions, and they can do some crypto functions. If you want to speed up TLS, apparently some of these chips can help. I actually don't know that much about these chips.
Greg in the chat said it's pull low to enable.
Yeah. Sorry, I'm really tired.
Oh no, have y'all watched the news? It's beyond garbage fire, because at least with a garbage fire, it gives you light, heat, and it gets rid of some garbage.
Anyways,
We're tired.
we're tired. Anyway, it's a neighbor with a bar over it. It's been a day. So you got the crypto wing, TPL 5100. Okay, so then I have. This is kind of that neat sensor I mentioned a few days ago. This is the AS7262 spectral sensor. So it's not a full mass spectrometer, but it's only a couple bucks, and it does 6 bands of spectral sensing. It has like 6 dyes. So this would actually be a really good one to put under the microscope when I get the sample in, because it'll have like 6 colored, squares, one for each spectral bin that it can do. And then this is that 9DOF sensor I've been kind of slowly chugging away on. I just made it a little smaller and kind of tucked everything together. Put XYZ markings on the side here. This is like a K-Town design. K-Town did these 2. And he did, these 3, and then I did, these 4.
How much time do I have on this tour?
I'm almost done here.
Okay, can I go downstairs and
Yeah,
Yeah, you can fill the space up.
I can fill space up. Go for it. I'll talk about stuff. Oh, maybe I'll look up the TPL 5100.
Yeah, I'll be back in like 2 minutes.
This is the Feather 328P. So once in a while, even though I'm not a huge fan of the Atmel 328 anymore, I really like the SAMD series. There are some times where I need to do checking with like libraries and sensors and stuff, and having a Feather for every platform that I tend to use does make things easier. And there might be people who want to, use some classic code that uses AVR library or AVR registers. And so this is a CP2104. It's a USB serial converter. You got your battery charger, your regulator, your reset button, and then RX-TX LEDs and the 328P running at 8 megahertz, and then a little bit of proto area. I'm not like, I'm not a huge fan of this Feather, but I think it'll come in handy. So I've kind of held back on supporting this chip in the Feather line, but maybe it's time. Then over here, I've got the new Gemma M0. I thought I was done with my Gemma M0 design, but I actually, as I've been working on the QTOUCH stuff and making more progress, I realized that this pin was capacitive touch capable, but on the previous design, these 2 pins weren't. They were on a Circom that didn't have those Y lines that could do capacitive touch natively. So it's like, if I'm going to make a Gemma, I should have capacitive touch on all 3 pins. It's just such a handy thing to have. So I decided to respin this, and then I changed these pins to be, they can still do I2C or serial, but they're also now capable of doing capacitive touch. Everything else is pretty much the same. This is more of like an internal change for me. And then over here is the tester for the NFC 50 on NRF with NFC 52832 Feather wing. So Feather. So this is a new Feather I'm coming out with. K-Town designed with NRF 52 module and support circuitry. And for this is the tester. So because the NFC pins are kind of close to each other, I decided not to try to other mill this. The other mill is not, it takes a really long time if you ever have really small gaps between pins. So I was like, you know what, I'll just send this out in this panel. So then I made the Gerbers for this, and I'm using my favorite software.
Did a Gemma M0? I'm just catching up on the
Yeah,
talk.
I did the Gem M0, and I talked about this tester.
Okay. This is like, it's not out yet, don't ask, but you can ask.
Yeah. And then this is the
What's your favorite software?
Zoff's PCB, which is called 3D Gerber Viewer. I love this thing. This is like the best software in the world because it does the 3D model. It does like a 3D model of my Gerbers, and it makes it look like it's really gonna look. And so I found that this is the best way to check Gerbers before sending them off.
Yeah?
Yeah, love it.
So
It's going to take a while.
It looks at it. And you can zoom in and zoom out.
Yeah, you can like twist and
This
stuff,
is
but
cool.
it's going to take a moment.
Yeah.
Okay, so there you go. So now I can like.
Is it in the
really see-
cloud or is it at your local?
No, this is local.
Yeah.
Yeah, which is another thing I really like. So you can see like rendering. Some things don't render completely right, but it's like 99% great, and it's good for checking silk screen, and also checking if something's missing from the back. Sometimes if you look at through a real Gerber viewer that's like just flat, it's hard to really see if you maybe forgot something. I don't have any bottom silk here, but just making sure all of my jumpers are there and
It's a neat
nothing's
trick.
missing. I kind of like it.
I like that it's running locally. I should, you know what? Let's promise ourselves something, Ladyada.
What?
If we say cloud, maybe we can also say other people's servers, because that's what it is. We
Yeah.
should just remember that. That's why it's nice. Like, you don't even need to be on the internet right now.
Yeah. This is sweet. So some of this rendering is, I don't know, it could be my fault too. But so now once I've got this going, especially like the really tight pack stuff, it's kind of nice to see a rendering. I feel like I can see it a little bit better.
Okay.
Yeah. Okay, so once that's done, I get ready to send this off. So I'm going to send off this panel.
Was that like written in Java or something?
No,
No.
it's written in something.
No.
So I like to send my prototypes through Gold Phoenix PCB. I'll tell you why.
Oh, before you get to that,
Yeah, what's up?
the one with the battery, is that another RTC feather?
No, it's a crypto wing.
Okay.
It has an RTC on it, but if you're doing cryptography, oftentimes you need to timestamp something, so having RTC is handy.
Oh, yeah.
So let me log in. So I like to order my proto panels through Gold Phoenix because they'll cut out and route every board, which a lot of prototyping services don't necessarily do. They'll send you like one panel, but Gold Phoenix does it, and they have a really good special. So I like to order my PCBs through them, and then I like to name my PCBs based on whatever article you've written in the week.
Oh, well, call this one Arduino Jeep.
It's too late. It's already called SparkX.
Oh, well, I wrote that article on...
No, because this PCB is already
you
was
already
designed
made it,
like
right.
2 days ago.
Oh, I thought... Yeah.
So
This
you were- so you were
morning,
writing.
I posted an article. It'll be on the Maker... I'm sorry, the Adafruit Daily newsletter tomorrow,
Yeah,
in the Maker Business newsletter.
yeah.
And it's about famous makers that have not only been on the cover of magazines like Wired and Popular Science and Make, but also have been celebrated by car companies.
Yeah.
Bree, former CEO of MakerBot, was in an Audi car commercial, and Massimo right now is in a Jeep commercial.
These are cool.
I cataloged those, I wrote those, and I put the number of views and when things come out, because I want to look back years from now and see what other things have stayed the same and what other things have changed. Similar to the SparkX article that I wrote about SparkFun,
Yeah, you're on a roll.
Nate specifically, the former CEO of SparkFun, doing limited run breakout boards with other mill prototyping and, skillets.
Okay, so back to engineering. So
Okay, I'll ask a question. Do the panels come in standard size or any custom size?
you use any custom size. So so like I've tried a couple different services. They'll have their pros and cons, but when you're sending out like 14 PCBs, like I am, but first off, you want to try to get it as square as possible. This just makes it easier to do the calculation of size. And then I just kind of like round up-ish. So this panel is 7.4 by 8.4 approximately. So that's what I put down. So 7.4, and then they quote you anyways for the full amount. So you upload your file, but then you still have to enter in all this info. So you set your board size, and then regular shapes. This is the thing that I really like. So I have all these like rounded corners here, or like the Gemma is round. So especially if you have weird shapes, and I do because I like to round my corners, I say they're not regular shape, but they are multi-project panels. And then the panel size is actually the same as the board size because I just want them to make this one panel multiple times. And I have to count the number of boards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Which count that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Make sure I don't make a mistake on that. So then there are 16 projects per panel. I don't need a date code or UL code. So they're not the regular shape. Multi-project panel, yes. That means I want them to be individually routed. I only want top silk screen, but I want two-sided mask. I can choose the mask color. You do pay a little bit more for custom mask color and custom silk. That's another thing. A lot of times when you order from PCB houses, you have to go with whatever color, like Osh Park does purple, or like some other places only do green. What I like here is I can pick all sorts of different colors, which is also a good time to experiment. If you want to experiment with colors, doing it now is like you only pay $20 and you can get an idea of what it's like. So like clear solder mask, I got that once. It's pretty cool. But in this case, I'm going to go with matte black. I like to go with different colors each time. The last few colors I did was light blue, red, and white. So matte black is next.
I like all these little tips and tricks because I see how many prototypes you do, how fast you do them.
Yeah, so like this one
And
is purple.
we have so many coming in. Oh, do you want to put on the overhead?
Yeah, like I can show.
Got a little box of goodies here.
Yeah, like I can show different color prototypes. So like, oh,
That's interesting.
hello. Well, I'll just hold it up. So this one's purple. Yeah, I don't know. It's plugged in.
Yeah, I don't know.
Weird.
I'll figure it out.
So this one's purple, for example, and then I really like the light blue. This is like a light blue one from earlier. And then, of course, there's classic green, classic red, black. Matte black is kind of cool because it's flat. It does show solder. Want to try again?
I don't know.
Yeah, weird. It's locked from, yeah. Sorry. Matte black it does look really cool, and it shows up the traces really well, but it doesn't, like when you solder, you get a little bit of like waxy look. Like it's hard to keep clean, but like if it is clean, like for prototypes, I think it's a little dirty looking, but for finished designs, it's really nice. If you're not, if you wash it and stuff. Anyways, so okay, so the number of layers, 2-layer design. You can do 4-layer or more, but all my designs are 2-layer. I don't really ever need more than 2 layers. Copper thickness, finishing, HAL. I just go with HAL. It doesn't matter. Silkscreen color, minimum hole size. All of my stuff, I try to keep it 7 to 15, 7 mil trace width clearance, 15 mil minimum hole size. Regular shape, no. Again, multi-part panel, yes.
See what happens now.
Huh?
See what happens now.
No.
Nothing. We got bad luck with that tonight.
Super weird.
Yeah.
Whatever, it's kind of cool looking. I don't really need it. And then what I do is, I do have some slots, so I'll tell them about that. These are USB pads or slots. So I have 1, 2, 3, 4. I think there's a 4. Yeah. My USBs are in DC jacks are kind of where the slots come from. So I have 4 slots, no other extras. And then I usually just say, look, you can do by area. Like they have a special if you do, 100 square inches or 155 square inches. I usually just say 3 panels. And the cool thing about the number of panels is secret tip. When you order from Gold Phoenix, they don't do testing. And for multi-project, they won't do testing for you. But if you get like 3 panels, I often get like twice as many panels. So it's like the 3 panel is a minimum. For stuff like testers or prototypes, I just say 3 because, whatever. That way I'll at least get 3. And it's, I think the price is pretty good. But, if you need more, you can do it by, inches size. If you have like one design, you can get like 50 of them for $100 or something. But because of the multi-project panel, I only need like 3 panels total. And then I get IP service. It's kind of the fastest service. And then 1-day turn. So let's do quote. And then they say they won't like give you a quote. Sometimes, depending on like how many parts per panel or whatever you have, you can't get a quote. But I'll just give you the quote because I know what it is. It's going to be $400.
See how that goes.
Yeah,
That's
there you
right.
go.
That's right.
Purple. What was it?
Who knows, man?
Man, who knows?
USB is weird. So we're gonna go into some question mark territory for a second.
Yeah, okay.
Yeah. Look at that. Isn't that nice?
Oh, you're using the
Mark.
the thing. That's
Yeah.
cool.
Well, we'll see.
I actually kind of like the question mark.
What's happening?
Okay.
All right.
Okay, so sorry, was there a question or are you just saying question mark?
No, that's when when I yank out the USB 3 video source live while having 5 HDMI devices.
Okay, so can you go back to the thingy?
Which one? Your
The
computer?
computer. Yeah, I'm just going to submit this quote. And then there's a customer requirements. I just sort of say, was it 16? I just write down basically what it is. It's a 2-layer, 1 ounce copper, we'll count FR4, 2-side matte black mask, 1 side white silk, 16 project, ship as individual PCB. They say customer requirements. I just put in basically a shot of what's going on, and then I say submit to quote. And you'll get an email in like an hour or two with the quote. I know it's going to be like $400 or so, and that was actually quite a bit. So you're probably like, $4 is insane. Well, number one, it's because I did 1-day turn. If you do a 5-day turn, it would be about half the price. It would be like $200. But for me, getting it like a week earlier, I actually do go through the prototypes pretty fast, and it will save me a lot of time. So for me, the extra $10 is worth it. Another thing is I'm sending out 16 different PCBs, and I'm going to get about 5 of each. So if you do the math, it's like 16 different designs times 5. So that's 80 individual PCBs. So 400 divided by 80, $5. I mean, I'm still paying about $5 per PCB, but I'm going to get these on like Monday or Tuesday. So today's Thursday. Well, I'll probably not get it Monday because it's I missed the earlier cutoff. But it's going to be, these are made in China. I'm going to have these PCBs go in before the next workday. They're going to ship Friday. They will fly in a FedEx jet over the weekend, probably arrive in the U.S. on Monday, get sorted, and then deliver on Tuesday. So really, really fast turn. And for me, $5 per PCB is totally worth it, especially since every time I get a new design out, it's like it makes money and it works out for me. And the faster I can do these revisions, the faster I can get things out. So this is part of like my workflow to be able to get 1 or 2 new designs done a week. You kind of have to be okay with spending a little bit of money to work fast. So there's a trade-off.
Yeah, I always look at it this way, like with you and your stuff, the only thing and the only entity that became our competition for our values and our goals and what we want to do is just time.
Yeah, time.
It's only time. And, ourselves.
Okay, so that's how you send out a panel. I've done it a couple times on the show, but people always like seeing how I get prototype PCBs
Who cut
made.
all these apart once you get them? Do you?
No, that's the thing. They come individually routed. They're perfectly routed. Like they actually come individually cut out. So I don't. That's the
cool.
thing. I used to get a panel, and it would be like one. I'd have to either like bridge them or something, or like put scoring holes and then like cut them, and then like it would be splintery. But when I get these, they come perfectly routed, exactly how they would from a final PCB, and they collate them and they box them together, and I've never had a mistake. I've actually also never, even though they are not electrically tested, I've never had an electrical issue with Gold Phoenix in the last 5 years. Maybe 5 years ago once I think I had one PCB that was bad, but since then I've had absolutely no problems. So This is, I use OshPark when I only have like a single PCB or 2 PCBs and I want them fast, but if I'm going to send out 16, it's just like so much faster to do it this way. So trade-offs in design, prototyping. So that's that. I will say that Gold Phoenix PCBs, they delaminate a little easily, so I use them for prototypes. I don't use them for production. Okay, next up. So that's done. Thank you. next up, updates on decompiling. So, as you can see on the oscilloscope, I poked a little bit today at the QTOUCH hacking. So one thing I did is I set up this Arduino Zero to do 2 capacitive touch sensors at a time. And one promising thing you can see is that when you test 2 sensors, it actually does 2 individual sensing. So that really gave me the hint of like, okay, there's a single capacitive touch converter in here, and it's multiplexing the 16 different inputs. So if you want to measure the 16 inputs, like it actually goes one sensor, then pull it high, and the other sensor, then pull it high, and the other sensor, one after the other. And so I set up actually ended up putting the code into Arduino. So probably if I wanted to do this most efficiently, like the smart way, I would have loaded up GDB and done this in, basically connected with OpenOCD. It's unfortunately been 20 years since I used GDB, so I'm a little rusty on it. So I was like, well, I could relearn GDB, but since I don't think this project was going to require serious debugging, I'll just do an Arduino and just printf the registers. So, back to the computer. After going through all of the code for the disassembly and the decompiled code for the QTOUCH library, I basically came up with what I think of as a pretty good register map. So these are the registers. I've got the select lines, the enable lines, the compensation capacitor, something called an int cap, and then of course the conversion result bottom and top, which is kind of nice. There's also an accumulator and something called the WCO threshold. I'm not sure exactly what that is. Some random init thing. Pretty good news. I think I have pretty much everything here for the QTOUCH ADC converter. And so I wrote a script basically in Arduino. Why Arduino? Because it's like, again, it's faster for me to get like serial print and any sensing, and like if I want to like do stuff, it's just faster for me to put this together in Arduino land, because I don't have to set up like circoms and figure out how to do that in AtML Studio. And AtML Studio was, because there's so many interrupts happening, it's all interrupt driven. AtML Studio wasn't doing a great job at helping me debug. Again, GDB probably would have been better, but I don't really think I need to go that deep. If I have to, I can always go there. So I wrote a little helper function called snapshot registers and print. And what this will do is basically read the registers at a base address, just like basically dereference that address location, save it in an array, and then I send it to this print PTC registers function, which prints it out very nicely so that I can see what's going on in the internals of the PTC manager while things are being converted. So I have it basically in a loop. In my loop, I do a QTOUCH measure, and then I have these little delay 5 snapshot, delay 10 snapshot lines. So the reason I'm doing that is because I want to see what was happening between, if I'm measuring 2 sensors, how does it know which sensor to measure? Because I want to sense any number of registers. I want to kind of be able to tease apart the code that enables the sensor, enables the overall peripheral and then enables the individual pin peripheral. So when I do a snapshot, I pull a pin high to tell me when that's happening. And if we go to oscilloscope cam, you can see here, it's a little noisy, but you can see this little pink bump here and a pink bump here. I think I'm not grounded properly.
You know what? I'm going to use a phrase.
Yeah, what's
that?
that?
I don't like this phrase.
Yeah.
Sometimes you and I talk about phrases.
What? Yeah, what?
And like, there's always these like.
I don't have a ground program. Yeah, okay.
These weird phrases like, oh, you can't have your cake and eat it too. Well, what else would you do with cake? There's a real big missed opportunity here. Why don't we have googly eyes on the oscilloscope?
I don't know.
Because it looked like if I put googly eyes and we pulled the camera back,
Yeah.
it'd be like the old Pee Wee's Playhouse things.
We should get.
Hey, the oscilloscope, and we did do a video with Adabot once.
Yeah, and it had eyes.
You know what? Now that we're doing oscilloscope, I'll do that. Every time we go to
Yes.
oscilloscope cam, I'll
Yeah.
have a little overlay. It'll say, "Hey, how's it going?"
Okay.
All right. Sorry. It was, but it's missed opportunity.
I know. Well, no, it's not
Yeah.
missed because you're going to do it.
I know. I'll explain a little bit. So like once in a while, we'll be talking to someone, and like something will come up, and they're like, "Oh, sorry, that was a missed opportunity." Anyways.
Okay. So these little bumps here, this is where I'm calling that PTC, grab the registers and print them out. So you can see I'm doing it right during the conversion cycle. That's what the delay is. And the clock to the PTC is really slow. I didn't mean to make it slow, but just because the way I just sort of set up the clock registers to be like, oh, just clock it from this clock. I'm clocking it from 8 megahertz, not 48 megahertz, so it's like 8 times too slow. Six times too slow. So it's slower than usual, but that's actually kind of nice because it's like, it just gives me plenty of time to do that read and print. And then when I go to the serial monitor, so back at my computer. Okay, go back to my computer.
Mm-hmm. I don't know what the computer's gonna, if it needs googly eyes. I don't think we can do googly eyes on the computer.
Not yet. I've got this is basically what happens. So when I do my first capacitive touch, I got these registers, and what's interesting is it's important to actually do the register reads while the peripheral is active, because the QTOUCH library actually sets up a bunch of registers and then like undoes them after it's done. So what I had been doing previously, like when I was doing this in Atmel Studio and I was looking at the registers, I was getting some info, but like I didn't have it set up so it would stop at the right point. And like again, it was like I was like, oh, I have to set up like the circoms to serial print output, or like tell me what point I am, and it got a little confusing. And I wasn't getting the register snapshot at the exact right location. And now that I can kind of fine tune by looking at that bump, that pin bump, to see exactly where I'm grabbing the registers, I can very easily say, okay, I want to grab them during the touch. So I see that some of the accumulators and some of the initialization, like the enable pins, the enable bits on the registers are set when later on they are taken away. So control register, got some enabled bits there. I don't know what this register is. I was calling it the initialization register. I've got the IRQ and flags register, the conversion control. I don't know what conversion control is. COD. Oh, it's the ADC accumulation count. So this actually, conversion control, the top bit tells me that the conversion is in progress, which is correct. There's an 8 there, and 4 tells me how many conversions have already occurred out of the total number. And then the accumulation amount goes here. So you can see this number, result L, result H. This number does vary. Right now it actually has the oscilloscope probes on it, so it's kind of high. I can remove those scope probes. And then you can see that the values are a little bit lower. 5D, 3F, 7C, 3A. And the reason those are a full 16 bits is I have 16 samples happening and it accumulates them. It adds them up all together. And the way you can tell is right here, for example, it says signals, the signal reading from the, why is this bumping up? Stay still. Hold on. This is 3A2 is the signal reading. If you go up here and you look at the high byte of the, it keeps doing, if you look at the high byte of the result, it says 3A, and then the low result is A4. Okay, I don't know why my serial port, hold on. I'm just going to put this into reset.
Oh, can I ask
Sorry.
a question while we're...
Yeah, no, it's okay. I'm just going to point this out. So the
Okay.
signal is 3A2, and then up here you see 3A, and then 29. So the question is, why didn't it return 3A29 as the result? Why did it say 3A2? Well, it's because I'm taking 16 samples, and then it basically averages them, it adds them all together, and it gives me divided by 16. If I had set it to only take 2 samples would give me, this signal would be half, 4 samples a quarter. Basically, it adds up all of the results together and then averages them, divides by the total number and returns it. So this definitely is the correct value right here. So that's kind of nice. So now all I have to do is I basically verified the number that I'm getting back from the library, 3A2, is the same value I'm reading in the register. Nice. Okay, what's the question?
Well, it's not related to this. Do you want
that's
to do
fine.
open questions?
Yeah.
Okay. Someone wants to send out emails from MicroPython with the ESP8266. Maybe, how would they do that?
I don't know if we have an email sending library yet, but you can look up SMTP example code.
Yeah, Greg said there's SMT library for MicroPython. Maybe
Yeah,
that
you
works.
can use that. And basically, it's sending email is actually pretty. You can actually do it at a command line. You telnet to like port 25, and you just type in hello and from and to. It's not hard to do. It's just you have to authenticate sometimes, and that's the tricky part. If you have to authenticate your mail sending, that's why we often tell people like, hey, for Twitter and email, if you can use if this then that as a broker, it can make your life a lot easier.
Yeah.
You don't have to off. So so the good news is we got all sorts of signal here. If I touch this, the signal changes. It's 306 when I'm touching it. When I'm not touching it, it's 200. So what I'm going to do next is I just have to basically learn how to kick off the conversion result. What's interesting is after the conversion is complete, some of the registers, like the control register, is zeroed out. So what the library actually does is when you set up to do a conversion, it actually sets up the entire peripheral. Some of the bits are already set, but it mostly turns on the peripheral, does all the conversions, and then shuts down the peripheral. Why? I don't know. Maybe it's like a power thing. Maybe it's like, well, why not? It's pretty easy to turn on, turn off. It only takes a couple cycles. But that's why you want to take measurements of the registers during the actual conversion, like while the peripheral is running, because the library turns them off after the fact. So good news there. Second thing I did is to make things easier, and also because I'm doing this for work, I did purchase a decompiling plugin for IDA, which is kind of neat. So, if I open up this program and then I can save as, is it save as? No, sorry, it's export, I think. Oh, sorry, produce file. And I can actually produce a C file, which is kind of neat. And it actually does decompilation. And so compared to the assembly code, the decompiled code is beautiful, very easy to read. It has, of course, some symbols for the library, the Atmel Studio code. So some of the code is it has register names and all that. But for other things, let me see. For example, PTC enable. That's the function we looked at before. Sorry, it's enable PTC.
Do you want to answer some questions about this?
One moment. So for enable PTC, if we looked over here, and enable PTC, it's not too bad. You can decompile this in your head. You call sync config, read this register location, or the value with 2, and then write it back. When you look at the decompiled code, it's much more elegant. It actually tells you memory location or it with 2 unsigned, and then return the result. So this is nearly identical to probably what the original C code was, and it's kind of lovely. It made it really fast. I'd started doing a bunch of these, and then I bought this license, and the license came through, and then it was I could very quickly check my math against this. But it's for code this simple, whereas a lot of it is just look, just to set the mode, you OR it, you AND it, you set it back. It's not too bad. Again, a lot of the function names were really helpful, and then the real stuff happens in a function called start cycle with callbacks. So, and because they have, again, these function names, it's not too bad. You know, you can see here, you enable run and standby, so enable it, enable the PTC. So that's the thing I was talking about. They enable and disable the entire peripheral. At the end, they disable it. And then, you know, there is this location, you can look it up. I believe this is the pin direction or mux. So, you know, it turns on all the different pins, disables the interrupt, clears the interrupt flags, re-enables it. You know, it's really good, clean and organized. Set up the prescaler, so this gets a little messy. It's like, what's going on here? There's a byte, pointer, D word. What's going on here is there is this huge array or the structure that you're sending into the function to tell you the setup for each sensor. So each sensor has its own compensation cap, resistor, timing. So this part here is where it is looking up all of those like individual settings and then setting them. So it's just what I just have to think about is like, okay, you know, I have to dereference those from it's actually faster to just set them in the code. So like over here in QTOUCH raw, you actually set the filter level per node here or whatever, the enable, you know, auto oversample, and then look at the registers and see what changes, then try to maybe noodle through you know, dozens of like dereferencing. You could probably get IDA to help you with all this, but for this code, it's pretty simple. I know that this variable is going to end up in a register, so I just like figure out what register that is and I write directly. Another question?
Yeah, so after the fat trimming, I guess we can call it that, were you able to make a smaller library, or do you think it'll be smaller?
It'll be way smaller. I haven't gotten to that. So basically what you saw on the oscilloscope is like the last thing I got working earlier today when I had like a few hours to check it out. So basically just getting those registers is where I'm at. And the next step for me is to actually start taking all this data, like I got all this information accumulated of this register map. So now what I'm going to do is look at this PTC start cycle with callbacks and basically rewrite it from scratch and set up all the registers and just see if I can, now that I know for sure that the conversion result is in, you know, 42004C1C, just try to get that to respond to touch. Like try to get this cycle going and then, you know, touch the wire I have connected to that pin and see if I can get that to fluctuate. Once I get it fluctuating, that means I have the analog digital converter reading the right data. Then it's just a matter of tweaking the sense resistor, the compensation cap, all these unknown variables. I just tweak them until I get pretty good results because I only need to set it once per board. Another thing I can do is, again, get it all working in AtML Studio, run it on the board, and then read those registers and see, you know, what did the library think was the best compensation cap or inline resistor or, you know, what have you. Or like, you know, frequency hop process. I don't know, like what's the best frequency hopping technique? I don't know, I'm going to try like all four and see which one gives me good results. And then that's pretty much it. Oh, you know, it's interesting because some of the variables, see, it's like the first time I'm looking at this function. Some of the variables, I guess, are global. They still had the names attached to them. So like sequence in progress, I guess, is a global variable. And so it's nice as it's identified here by name. Symbols are great.
Okay.
And then start PTC acquire. So this is the setup to get all the registers set up. And then it calls start PTC acquire. So this is another one I'll have to rewrite. But I think another thing that the way this library works that I don't super dig is it does all the readings at once, which makes sense if you're doing a scanning interface, but may not make sense if you are like doing Arduino type programming.
Yeah,
you want to just read that one pin at a time.
You don't need everything.
You don't need everything. So it's definitely going to be faster in that respect. And it's definitely going to be a lot less bulky because there's a lot going on. There's a lot of XY mutual capacitance stuff and like all this configuration. And again, I'm not going to be doing as much calibration because I'm going to set it up to calibrate per board once and then it's done. Like I'm not making a utility that has to work in like, you know, 0 degrees centigrade and 80% humidity. It's like it's a learning board for kids in school. If it works fine, it works fine.
So here's a question. When you're doing this type of reverse engineering, do you ever find any bugs? Like something that this code has in it?
It's tough because I'm not. That's not
Hard
looking,
to know for what
I'm
the
not
bug,
looking
yeah.
for that. If I'm not looking to break it, if you're looking to break something, you will find bugs because that's kind of, it's like. I remember like there was this news like, oh, some root exploits were found in Android, and people were like, yay, there's another way to be able to, like it's not like they're not worried about like people exploiting your phone from the outside. It's like this allows you to jailbreak your own phone. So if you're looking to jailbreak some code or hack some code, you would look for weaknesses or places where maybe bounds aren't checked or the input isn't sanitized. For me, I'm actually just like I want to. This isn't reconnaissance. I just want to get the goods and get out. Like I don't really care too much about the QTOUCH library. It doesn't matter to me how this is written. I'm just like trying to get that command list for like how you set up this peripheral to get it working, and then I'm out. Like that's all I care about. I just want to get rid of these resistor packs on my circuit playground.
Okay. All right, is that your show for tonight?
Well, I think it's 11. I think that's good.
Yeah, man.
Yeah, I think that's
You
good.
thought you were going to do a half an hour. You almost did an hour.
Well, I had 2 things. I got more
Yeah.
things, but I think that's a good one.
All right.
So I actually like I really need to take a break, but I'm seriously going to try to get the QTOUCH stuff done this weekend because it's been lagging. But now I got some really great stuff going on here. Viewers can send in ARM code that they want decompile it live on the air. Yeah, so this is fun. We start PTC acquire, and then there's actual PTC acquire. Let's see what PTC acquire is. Oh, it's actually just set this bit 4C0D. So it's not too bad. Yeah, conversion started. So that's the bit you set and the bit you check. So yeah, it doesn't seem too bad. I mean,
The bit you set is the bit you check.
that's true. So probably I will, next time we do a stream, maybe tomorrow or Saturday or Sunday,
Yeah.
I'll write the function that actually gets that started. And then what I'm going to do is, I'm not going to replace all the QTOUCH code at once. I'm just going to get the acquisition stuff replaced and get that working. And then once I have that working, then I'll go back and replace the initialization code, which just sets up all the registers. Again, like not too, okay, I already have a snapshot of the register, so I know what to set. And then finally I'm going to wrap it up in a nice Arduino package with a bow on top. And I'll publish it so that people who are using the SAMD chip will find it handy. And I think they will, because this is like free capacitive touch on like half the pins. It is pretty sweet.
Yep. All right. This one's for all those kids out there who share their projects online, maybe on YouTube.
Do you have a message for them?
Sparky has a message for them.
Okay.
Maybe they share it and the site picks it up.
Wait, there's a cat.
Yeah.
But
well,
the cats get scared now.
He's gone.
Hey.
But Sparky has a message for you. For all of you who choose to share things online.
Don't read the comments. Don't read the comments. Don't read the comments. Don't read the comments. Don't read the comments.
All right, Lady. Well, that's our show. Kevin mentions that one way to do debugging with GDB is to use DDD. He does that under Linux. Doesn't know if there's a program under available for Windows.
Oh, I run Sigwin,
Yeah.
which is a nightmare, but it does work. And that that would be fine. You can also probably run something under VirtualBox. If open, you just have your OpenOCD on like Windows side, and you open up a port and just make sure that you can get to that port. I do want to try getting back into using GDB again. It's been 20 years since I used it, or something insane like that. Maybe I used it in college a little bit, but yeah, it's always tough when you have interrupts going off. Like ML Studio it would crash, or it would just it just didn't like it. because the problem is that the interrupt. So in QTOUCH, it's all interrupt driven. Like it sets up the procedure, but then it does callbacks to actually get the data. I don't know. I know the entry for the callback, I guess. I mean, I don't know actually if it's the vector table it includes that point. It probably does somewhere, but I don't know where the function. But that calls some other function calls another function. I don't know where those are in memory, and I don't really care. It doesn't matter to me because I know from decompiling it that that register location, those 2 bytes of register location are the low and high bytes. So, that's where it is. I'll just grab them. I'll just pull the bit and just grab them when they're ready.
Okay. Well, that's it for tonight, Ladyada. We'll hopefully do a Desk of Ladyada probably sometime before next week, but just tune in, subscribe, like, share, do all that stuff. It helps us. And, of course, pick up something at adafruit.com. And that's it.
Cheers.
Yeah. Later.